Good morning, all. Myself, Arshad. I am currently pursuing BTech in the stream of Computer Science and Engineering at Srinivasa Ramanujan Institute of Technology. Today, my topic for this session is Orientation, Polarization, Engineering Physics. Introduction to Orientation Polarization. Orientation polarization occurs in dielectric materials when polar molecules align themselves in an electric field. The phenomenon is crucial for understanding the behavior of materials in capacitors and other electronic devices. Orientation polarization is one of the three main types of polarization along with electronic and ionic polarization. The main polarization according to is orientation polarization, then the electronic and ionic polarization. Mechanism of orientation polarization. In an external electric field, permanent dipoles tend to align with the field direction. The extent of alignment depends on the strength of the electric field and the temperature of the material. As the temperature increases, thermal agitation can disrupt the alignment of dipoles, reducing polarization. Here we can see the electrons are assembled in different shapes. The strength of alignment depends on the strength of electricity. Therefore, the strength of alignment, when the polarization is done, when the electrons are aligned in a direction, it depends on the electric field and the temperature of the material. It depends directly on the temperature of material because the temperature of the material influences the extent of alignment. Factors affecting orientation polarization. The strength of the electric field significantly influences the degree of dipole moment. The type of material plays a crucial role as polar materials exhibits stronger orientation polarization than non-polar materials. Temperature is another important factor. As higher temperature can lead to decreased polarization due to increased molecular motion. The strength of electric field, influences the degree of dipole. The temperature mainly affects the orientation polarization process because orientation polarization is inversely proportional to the temperature. If the temperature increases, the polarization decreases due to molecular motion. When the temperature increases, the molecular motion also increases, which affects the orientation polarization. Thus, thus the orientation polarization is affected by temperature. Applications of orientation polarization. Orientation polarization is utilized to design the capacitors, enhancing their efficiency and storage capacity. It plays a key role in functionality of various sensors and transducers and improving their sensitivity. Understanding the phenomenon aids in the development of advanced materials for electronic and optical applications. Orientation polarization is used in many ways, which plays an important role and crucial role in our day-to-day life, whether in electronics or various sectors, because it is utilized to design the capacitors. It plays a crucial role in the design of capacitors, which helps in improving their efficiency, storage capacity. It also plays a crucial role in various sensors and transducers, improving their sensitivity. Understanding the phenomenon aids in the development of advanced materials for electronic and optical. It also used in optical applications also. Comparison with other polarization types. Orientation polarization differs from electronic polarization, which involves the displacement of electron clouds rather than molecular alignment. Ionic polarization arises from the displacement of ions in a crystal lattice, making it relevant in ionic components. Each type of polarization contributes differently to the overall dielectric response of materials because it is quite different from the other polarization process like electronic and ionic polarization, which involves here orientation polarization involves in the displacement of electrons clouds rather than molecular alignment. Measurement of orientation polarization. The dielectric constant of a material can be measured to interfere infer it orientation polarization characteristic. Techniques such as dielectric spectroscopy are employed to analyze the frequency-dependent behavior of polarization. The measurements help in determining the effectiveness of materials in specific application. Role in dielectric materials. Orientation polarization plays a significant role in the overall dielectric properties of material. It contributes to energy storage capabilities and making materials suitable for insulators and capacitors. Understanding orientation. Polarization is essential for enhancing performance of dielectric materials in various applications. It may filling capacitors, heat, high heat wire, sensor wiring, insulation jacks, motor gen winding, and cable insulation. Limitations of orientation polarization. Orientation polarization is limited by the thermal process of molecules, which can disrupt alignment. In high frequency dielectric materials, the response time of dipoles can be insufficient, leading to reduced effectiveness. Certain materials may not exhibit significant orientation polarization due to their inherent molecular structure. Future research directions. Ongoing research aims to develop new materials with enhanced orientation polarization properties for advanced application. The integration of orientation polarization with other types polarization may result in smarter materials with tailored properties. Conclusion. Orientation polarization is a vital concept in understanding dielectric materials and their application. Its significance spans various fields including electronic materials and science and nanotechnology. Continued exploration of this phenomenon will pave the way for advancements in technology and material design. Thank you for giving this opportunity.